Boo. Okay, here we are. I feel like I'm in the Twilight Zone. There's nobody in the classroom, and I'm just kind of like feeling like I'm sitting here talking to myself. I'm going to try to recreate my small group lessons just how we normally would. It'll just be a little bit different. All right, so let's go ahead and get started. Everybody take out a pencil. Wait, what? No, I don't have a pencil. I don't know, go get a pencil. You need a pencil too? Where's your pencil? You lost it? Oh. All right, everybody take out your notes from weathering, erosion, and deposition. Why? Where's your notebook? In your locker? Go get it. It's almost the fourth quarter. Go get your notebook. What, you were not absent the day we took these notes. You were here, I remember. All right, guess what? I won't have to worry about that for a while. So hopefully this will make it even a little bit easier for you because you will always have your pencil. You hopefully have your science notebook, or you'll be just keeping everything digitally on your iPad, and we can just move forward from here. All right, let me get off my countertop. If you saw what my classroom looks like right now, it looks more like a TV production studio. I've got my big bright lights that are normally in the back of my classroom up close to my face so you can see me. Okay, so on Monday, the day that school closed, I was supposed to be working with the B's on weathering, erosion, and deposition, and the A's were supposed to be doing geology chapter 13. So I've got to figure out a way to get the notes to the B's, but I will get on that as soon as possible. So on Tuesday, yesterday, we would have kicked off layers of the earth, and this is very close to what I would have been doing with you guys. Although, I think there was a couple like hands-on activities that obviously we won't be able to do. But here we go, let's get started. So the ground that you're actually standing on changes in composition and density as you go all the way to the middle of the earth. So the part that we're standing on is a solid, and then when you go into the layer that's called the mantle, it actually turns into silly putty because of the heat coming from inside the earth. And then when you get back into the middle again, it turns into a solid because of the tremendous pressure that is being put on it by the gravitational pull of Earth. Here is a great way to kick off thinking about journeying to the center of the Earth. This is fictional. This is not real. It's just for fun.
Okay, there, stop.
Walk back exactly the way we came from. Very, very calmly, okay?
Try like that. Heel toe. Doing good.
Doing great. Very slowly. That's it. It's great.
Really careful.
Keep going.
It's actually thicker than I thought. We're still falling!
All right, so it's a good idea maybe to watch that movie if you have it at home, but that was just a little, kind of just a fun attention grabber. All right, so you know we always read our I can statements out loud, so I'll read it, and I expect you to be echoing me as you're watching it at home, just like we do in the class. Ready? I can. Oh, it's just not as fun. Obtain and communicate information about the relative position, density, and composition of Earth's layers. So that is sort of where we are for this day 1 and day 2 of e-learning. You should have already done these words in the Quizlet activity that was in day 1. So you should be familiar with density and composition. So density is, like, remember how tightly packed something is, and composition means what it's made up of. All right, here are a couple pictures, because you're going to see pictures that are kind of cutouts in different ways, and sometimes it's hard to understand exactly what you're looking at. So if I took the Earth and cut the ball in half, this is sort of what it would look like. And you can see that the inside is a marble. That's acting as the solid middle of the Earth, called the inner core. And then there was kind of like a sort of a liquidy, I think I used slime, but it dried up from last year. So that would be the outer core. The putty, or the clay that's kind of orange looking, that would be the mantle. And then the Earth's crust is kind of like the sandy bits that are around the edge. So if I took the ball, if I took Earth and just cut it in half, like I'd cut an onion in half, this would be sort of what you're looking at. Now, then you get a picture that kind of looks like this. That would be sort of like, let me grab my globe. So it would be like if I could stick my hand into the middle, grab it, and kind of pull out like a slice. That's what you would be looking at right here. So this is continental crust. Obviously, that's where you're standing. Then underneath the oceans are something called oceanic crust. Then you've got the mantle, which has an upper and lower mantle, an outer core, and an inner core. And then this was like kind of what the cutout looked like. Now, composition means you need to know what they're made up of, and you don't have to like memorize every single thing, but you should know that the continental crust is made from granite, the oceanic crust is made from basalt, and sort of as you go into the middle, it becomes a combination of nickel and iron. So one thing we would have done right now when we're talking about density is we all would have gotten 3 different rocks, and we could have like explored the density. So when you pick up basalt, it would actually be the lightest. When you picked up granite, it would feel a little more dense. And then when you picked up the nickel, it would feel extremely dense, meaning it has a lot of weight to it. So that kind of explains how things have settled the way they have. The more dense material has kind of fallen towards the middle, and the least dense material is sort of like on the outside shell. All right, believe it or not, let me go back to my little picture. Actually, let me go back to this picture. Believe it or not, we have not even drilled through the crust. So we cannot even get a drill down into here. We have never actually drilled all the way through to the mantle. The drills don't last, they break. We don't really have anything like hard enough, even like diamond tipped like drill bits. We don't have anything kind of to keep going. One thing I think is interesting is that at the same time we were in a space race with Russia to get to the moon, we were also in a race to drill down into the Earth. So didn't make as much, didn't make the headlines like the moon thing did, is because we still, even since 1970, we still haven't gotten anywhere yet. So the next video I'm going to show you is a clip. It actually was, I think, from 2014, where they thought like, oh, really soon we're going to be through into the mantle. And yeah, we still haven't gotten through the mantle yet, and this is like 2020. So here you go.
The water here is over 2 miles deep, but that ship is drilling into the bottom, obtaining samples of muds and rocks for scientific analysis.
In 1961, scientists drilled a hole into the ocean floor off California's coast. They hoped to break through the Earth's crust and reach the mantle beneath, but they failed.
Now, other scientists are trying to make history again. A 2-month expedition in the Indian Ocean has drilled farther than ever before and returns to land today with samples that could help unlock some of the Earth's deepest secrets. Jeffrey Kluger, Time Magazine's editor-at-large, has been following the team's efforts and joins us now with more. Good morning.
Good morning.
You of all people know that sometimes science scares me.
Yeah, it scares me too.
But it doesn't seem like a good idea to drill into the core of the Earth. What comes out? What are they trying to do?
Here's the thing. We all think if you drill that deep, you're going to pop the Earth and we're suddenly going to deflate. But the fact is, where they're going is the mantle, which is 85% of the Earth. So the largest part of the Earth we know nothing about. If you get into a deep enough part of the ocean where the crust is thin enough, you can actually sort of get a head start and drill down into an area of the Earth where you get pristine samples that haven't seen light since the earliest days of the solar system.
Wow. So as we mentioned, they first started this back in 61. They got down pretty far, but they stopped. Why? What happened?
Well, a couple of things happened. First of all, they had some technical breakdowns, but also 1961 was the point that America began looking up at the moon, not down at the core of the Earth or at the mantle of the Earth. So funding dried up. And
we lost interest.
We lost interest. It was either guys in silver pressure suits or roughnecks on drill boats, and there was no competition.
But we have had other samples of mantle before, of the crust before. What's different?
Well, we haven't actually gotten down to the mantle. We've gotten close. And what they've gotten to on this first expedition, this first round this time, was about 2,300 feet down, which isn't bad, because if you can get 1.6 miles down, you are in the mantle. So they've gotten closer than they've ever gotten before, and already they've brought up the largest piece of crustal material. So they're learning more about the crust as well.
What are we hoping to find in this material?
Here's a couple of fascinating things. First of all, seismic scientists know that when you get below a certain level, it's called the Moho Discontinuity, a term I love. It sounds like gibberish. It's a great term. Exactly. But it's where seismic waves speed up. And if you learn more about those seismic waves, you can learn more about earthquakes. You can also maybe find extreme life forms that deep down.
Really? So what are the life forms they think?
Well, you have life forms on Earth called extremophiles. They survive in extreme environments, down at hot vents, locked in desert rocks. Here, it's possible you will find forms of life that are that deep in the Earth that live on methane. And living on methane is sort of a template for extraterrestrial creatures.
Wow. All right. So this was only phase 1 we've seen. There's phase 2 and 3 still?
Phase 2 and 3. They hope to have this done sometime within the next 5 years. They've gotten down to, say, half a mile down. They need to get down to about a mile and then 1.6 miles, and they feel that that could happen by 2020. And when they do, it will be the first ever historic sample of mantle.
Is there any exciting prediction for what they might find?
Well, again, the hope is, first of all, that you'll get a sample of the solar system in its earliest phase, because this is material that hasn't been touched since the solar system was formed. And also, this idea of life forms, this is a way that will give us a sense of when we go out to the moon, Titan around Saturn, when we go out to the moon, Europa. These are the kinds of organisms we could be looking for.
I cannot even imagine the drill bit one has to have.
Yes. And some of those drill bits are broken because you get down to brittle material that actually clogs it. And, you break a tool.
All right, so pretty interesting stuff. And that video, I hope you saw, it was from they estimated to be into the mantle by 2020. No, not close yet. So they're still working on that. So this is sort of the graphic organizer that you're going to use to take your notes. And I'm going to show you on the next page kind of how it's going to work out. But basically here is another sort of cutout of the Earth. All right, so you're going to see pages like this, and it's going to show you position, composition, density, and thickness. And right here you can see you've got position, composition, density, and thickness. So basically you're taking these notes and you're putting them into here. Now I know it seems silly because you could also just kind of memorize your slide, but remember when you take the time to actually type it or draw it with your finger on your own, it sort of helps to solidify everything. You do need to know about density, but all you need to know is that the least dense is the crust, and density increases as you get to the middle, as you get to the core. You do not need to memorize the density of each layer. You will need to know the composition, and remember the continental crust was granite. I think I already showed you a sample of that. And you probably can find this stuff like around your yard. All right, you're going to continue through this PowerPoint and you're going to fill in your graphic organizer. So that's going to be like in the assignment like that's after this one. Remember, we usually go over these notes and do some different activities. We do partner reading, we kind of quiz each other. So I am encouraging you to use FaceTime or, you know, even texting, reach out to other students that were in our class, and you can quiz each other, you can read these notes to each other, you can read them out loud to your parents, because remember that story about my son when he would come home from school and I'd be like, what did you learn today? And he'd be like, I don't know. And I'd be like, how can you be in class and not know what you learned? And he's like, well, I know what it was, Mom, but like I don't know how to say it. So please make sure you're saying these words out loud, reading them out loud to your parents, because that really helps you understand what you're trying to learn. All right, so I'm not going to go over these individually because you're going to do that on your own. I do want to go down to the mantle because this is the largest layer, and it has something in it called convection currents. So you will have a lot of questions about where do the convection currents happen, and you're always going to say in the mantle. Now what convection currents are, remember it's sort of like when things get heated up, they sort of rise. So as this silly putty gets heated up, it sort of comes up to the surface. When it's away from the middle of the earth, it cools off and it sinks back down. And that is sort of how our tectonic plates are going to move. And I know we started talking about that just a little bit, but the convection currents are what's going to drive how the big cracks in our crust are actually moving around. So here's another like kind of image. So you might see one that's sort of like the surface of the earth, and then you also might see one that's sort of a cutout. So I don't want you to get confused if you see different images. So they're all kind of the same thing. And here is a video on sort of what is happening in the mantle.
Hi, I'm Jared. Welcome to Fun Science Demos. The big idea today is that heat moves matter. Heat moves matter in this lamp, and heat moves matter in our Earth. So let's take a look at this lamp and see heat move matter. You can't see it, but there's a light bulb here, and it's hot. It gives off lots of heat, and that heat heats up this purple wax. You can see it. Woo! It causes it to rise to the top. When that wax gets hot, it rises to the top. And you can see some of the wax dropping down. Why? Well, as the heated wax moves to the top, it just hangs out there. And it's cooling off. And when it cools off, it drops. It drops back down. And when it drops back down, it gets heated back up and moves up. And it cools off and moves down. And it gets heated up and it moves up. And it cools off and it moves down. It's this cycle. It's happening in the lamp. And what do you know? The same thing happens in our Earth. So let's take a look at this diagram and see how the Earth works. Through science, we've discovered that the middle of the Earth is really, really hot. We've also discovered that the outside of the Earth has this crust, and the moving matter inside the Earth can actually move the crust. As it's heated up, it rises up to the crust, it cools off and comes back down, just like this lamp, the wax in this lamp. It's happening inside of our Earth. The heat from the middle of the Earth is causing all this matter to move, and that makes the crust move. So let's take a look at that crust and the outside of the Earth. These are continents. That's where we live. The blue is the ocean. Oceans and continents actually sit on top of the crust. Well, what are these lines? Through science, we've discovered that the crust is actually broken into plates, and those plates move. Heat moves matter. Let's try and show you how that works. We have a heat source here. We have a heat source here. We have a heat source here. Our heat source is the middle part of the Earth. We need something to be the matter that heat energy can move around. We have our milk. And now we need something to be the crust. For that, we're using chocolate powder. So here's our setup. We modeled it after our Earth. We have our center hot part. There's the heat source down there making it hot. We have our crust. crust, which you can see on the top, it's smooth right now. Something should happen as the matter, which you can't see, the milk, starts moving inside from the heat. Heat heats it up, rises, cools off, and sinks. There's movement happening. You can't see it yet. Let's zoom in and take a closer look. So our timer's going. Let's take a look at this setup and see what's going on here. Inside the pot, we have our liquid matter, much like the Earth, and we're heating that liquid matter, much like the Earth. The cracks get bigger. Watch right here. Watch it open up. Watch right here and right here. Ooh, there's one forming right here. Now we have a crack forming here. The crust is breaking into plates right before our eyes. Why is that happening? The liquid matter underneath the crust is moving. Now we can start to see it happen. You can see the plate movements. As that liquid matter heats up, the crust, the plates move. Cracks are forming. We're at about 15 minutes in, and now we can see.
All right, with parents' permission, I would encourage you to any experiments you see here. No, class is not over. Sit down, sit down. All right, just kidding. All right, so you can try any of these experiments, with parent permission at home. All right, so the outer core, the inner core, and that is all we have for today. I will be making another video when I go over the continental drift notes. And I also wanted to show you my density column. I think in day 4, we're gonna be talking a lot more about density. But you can kind of see that I have a bunch of different materials. I'm trying to get it in the light. Have a bunch of different materials that have different densities. So it's kind of like alcohol, corn syrup, dish soap, isopropyl alcohol, ethyl alcohol, and you can see how everything kind of settles differently and doesn't mix. This is exactly how the layers are formed inside of our Earth. This is how they stay kind of separated from each other. They all have different temperatures. They are all made of different things, different compositions, and that is pretty much the goal of what you need to do. Remember that I can statement. You've got to know the position. That means the order. Do it from the inside out and from the outside in. You've got to know the composition, what each layer is made of. You have to know the density. You don't have to memorize the exact numbers. You just have to know that the ones that are more dense or have a higher density will be down towards the inner core, and the least dense materials will be sort of on the crust or to the top. All right, I'll be making another video. I already said that. And okay, so you guys are dismissed. No, yeah, you can go to the bathroom. Yeah. No, yeah, you can go to your lockers. Yeah. Okay. All right, I'll see you tomorrow. Bye. Oh, gosh, I got to get up here to shut it off. Oh, peace.